What's up, everyone? So for today, I want to talk about refraction. I mean, refraction. Okay, refraction. Okay, so refraction simply means the bending of light. Okay, um, bending of light. Okay, that is simply refraction. For instance, if light was traveling in this direction, then it bends. Then you can say refraction as occurred. Okay, this is what refraction is: the bending of light as it crosses from one medium to another. That is refraction. So when light travels from one medium to another, it tends to change its direction and sometimes even its velocity. Yeah, that is true. Its direction and speed. Okay, so sometimes it does those things. Okay, so we want to talk about refraction. I want to use the medium glass to air. Okay, refractive index. What is refractive index? Okay, refractive index is equals to sine I over sine r. Okay, sine I over sine r. What is I? I is angle of incidence, r is angle of refraction. Okay, so this is refractive index. Okay, now we want to understand something that happens in our everyday life. For instance, let's say light travels from this medium right now, and the light ray was bent. Okay, now a line that you draw to create orderliness, okay, you can call it the normal. Okay, you can call it the normal. Okay, if we put this on a plane like this, then this is the incident angle. This is the incident angle, and this is the um, refracted ray, refracted ray, then incident ray. Okay, the angle which the line of incidence makes with the horizontal is called the incident angle, which is I. Let's call it phi. The angle which the refracted ray makes with the normal is called the refracted angle. Angle of refraction. Let's call it theta. Okay, so refractive index, okay, is equal to sine phi over sine theta. Angle of incidence or angle of refraction. Okay, so let's see what happens, okay, in our everyday life. Okay, so if light, a ray of light is pointed to a glass, here's what will happen. If a ray of light, okay, the path through which, if a ray of light is pointed to a glass, okay, here's what will happen. We don't want to perform that experiment now. Here's what will happen if a ray of light is pointed to a glass. Okay, the light is going to come and strike the glass, then it will bend away from the normal. Okay, this is how it will look like. See this one, the ray bent toward the normal. Now this one, the ray is going to bend away from the normal. Okay, now this is the refracted ray, this is the incident ray. Let's say the medium is from glass to air, from glass to air. Okay, so that is it. So light is trying to travel from glass to air. When you point a ray of light to a glass, and here's what will happen: the ray of light is going to bend, it's going to go away from the normal. Okay, so light in this case is traveling from glass to air. Okay, So before the light hits the glass, the ray was okay. Then after hitting the glass to the air, this is the result. So trying to understand the path of the ray of light from the glass now to the air. Okay, so you see this now, you can have here as phi and have here as theta. As you can see, for air traveling from the glass is denser than air, right? From air traveling from a denser light traveling from a denser medium to a less denser medium, from a denser medium to a less denser medium. Yes, what will happen? The ray is going to bend away from the normal. You are going to have the angle of refraction and to be very, very big. Okay, then the angle of incidence or the angle of refraction will be always bigger than the angle of incidence if the ray is traveling from a dense medium to a less dense medium. Exactly. So that is what you have here, and this is what you have here. So right now we want to understand. So in this case, for light traveling from, there's gonna be the angle of refraction will be more than the angle of incidence, and thus leading to probably a higher refractive index and etc and other stuff. So let's see what happens right now. Let's see what happens. Okay, and why is it that objects appear bigger? Okay, why do objects appear bigger? Okay, when you look at an object in water, why does it appear bigger? Let's see the two cases, special cases we can have in real life. If light is traveling from a dense medium, okay, from a denser medium to a less dense medium, yes, so from the ray of light is going to bend away from the normal, right? It's going to bend away from the normal. Now, what will now be the position of the image? This is R, this is I. What will be the position of the image? Okay, the position of the image we then follow this path. The angle of the ray and the refracted ray, you're going to just follow it down and trace. I don't know if I'm doing it correctly, if I had a ruler here. Okay, trace. So now you would see the image probably overlap with the image overlap with the object, the main object. This happens when you we have experiment on that. We have a short video on that. This is the first case. The image will kind of overlap and we shift probably to the back of the object. This happens when you put objects into water. You will see the difference. You will see image coming back at the back of the main object. Okay, if you immerse this now into a water partially, you would see the image probably coming out to the back. Okay, do that experiment at home. Get a glass cup and turn water in it. Get object, just put it inside a bit and check. You will see this. Okay, the image will appear either at the back like this and maybe smaller than the initial object, or it will happen this way. Okay, if the light is traveling from a less dense medium to a denser medium, the light ray is going to be bent towards the normal. Okay, and where will be the image? Where will be the object? The image of the object will then follow this path. It will then come this way. The object will be very, very, very big. Let's call it arrow prime. So the object will be big. So when you look at something in water or any medium and you see, hey, this object in this medium appears bigger, just so that it is so because light is traveling from a less dense medium to a denser medium. From a less dense medium to a denser medium. Example of this is the you will see the image very big. Okay, to even overlap the of the object. The image will overlap the object. So this happens. The perfect explanation to this situation is when you turn water into buckets, what happens? You see the objects become the buckets become bigger, okay, at the bottom, and this is as a result of the fact that light is traveling in this case from air, which is less dense, to water, which is denser. Okay, that is why the objects appear bigger and closer. You see the object is going to shift position. Okay, instead of here, it's going to come and overlap. Okay, it's going to be very big. Okay, you know that light is traveling from a less dense medium to a denser medium. Okay, from less dense medium to a denser medium. Okay, so in this case, to explain this, light is traveling from air to water. Air is less dense, water is denser. Just turn water into a bowl and see the bottom of the bowl appears closer. It's as a result of the fact that light is traveling from less dense medium to a denser medium. Or in this case, if light is traveling from a denser medium, if light is traveling from a denser medium, if light is traveling from a denser medium to a less dense medium, okay, or a less dense medium, the image will appear at the back of the initial object. This happens when you immerse things, when you immerse a chalk or a pen into a glass of water. Okay, you will see the image at the back. Okay, sometimes you see it at the back. You see the image, and the image may overlap with the object. If you draw this very well with your ruler, you will see the line may follow. It's going to come to the back. It may overlap with the initial object depending on the angle. Then also it's going to always come to the back. Okay, that's why when you put objects in water, usually you see the objects appearing at the back of the image appearing at the back of the main object. The image of the object through the water will appear at the back. Okay, so just make sure you check this one with just make sure you check it. Do that experiment. Okay, a glass of water, the hard object to it, so you see what happens. But if the object appears at the back, or the object happens to be smaller when it enters that medium, understand that the light is traveling from a denser medium to a less dense medium. In this case, the object will be bigger, while the image will be bigger than the object. Okay, while in this case, you see the object becoming smaller. Okay, understand that light in this case is traveling from a denser medium to a less dense medium. Less dense medium, air; denser medium, glass. Okay, glass is denser than air. Okay, so this is everything. So I hope this will help you understand why objects appear bigger when viewed through certain things, and why they appear smaller. It's because light is either traveling from a denser medium to a less dense medium, or from a less dense medium to a denser medium.